This is section 8.5, solving linear systems using matrices and row operations. So first, let's just take a second before we get into the section. Before this, we've talked about different types of linear systems, right? 2 equations with 2 variables, 3 equations with 3 variables. So now this is just kind of another way to solve those, okay? All right, so first, actually, we're just going to start off with a couple examples to get us back into solving systems. So first, we're going to actually start off in Alex as the identifying the operations used to create equivalent systems of equations. It's a mouthful. So that will be what we'll look for here. What was it called? Identifying the operations used. Okay. So, identifying, nope. Oops, helps if I could spell. Okay. I thought I had the Y there. Equivalent systems. There we go. So this one here. Okay, so it looks kind of odd, right? We just are trying to figure out what happened from system A to system B to system C. Okay? So, very first question, how do we transform system A into system B? Okay, so we want to do what here? We want to, let's see, we took negative 4x plus 5y equals 8. We didn't do anything to the first equation, right? So A1 to B1 did not change. So then let's look at A2 to B2. 7x minus 6y equals negative 3. That definitely has a difference, right? 7 to 28, that's 4. So let's make sure the rest of the equation has a 4 difference. So negative 6 times 4 is negative 24. Negative 3 times 4 is negative 12. So that just means we changed A2 to B2 by multiplying by a 4. Okay, so then how do we transform system B into system C? So let's look here. What changed again? B1 to C1, same equation still, so it's not that one. Then B2 to C2. Well, that changed, right? Well, what changed about it though? Because we only have y left. So let's actually take this for a second and write these down and figure out kind of what happened. Okay, because there's some elimination that happened there. Okay, so if we have the equations negative 4x plus 5y is equal to 8 and 28x minus 24y is equal to negative 12. What did we do here? Well, we want 11y is equal to 44. So that means we want to get rid of the x's. So we want to get rid of these guys. So that means negative 4 to 28, that's a 7 difference. So multiply this first equation by 7. So that gives us negative 28x and then plus 35y is equal to, what's 8 times 7? 8 times 7 is 56, right? Yep, 56. So now we want to take these 2 equations and add them like normal. So 28x minus 28x, no x's, negative 24y and 35y, that's 11y. So then 56 minus 12, that would be 44. That's exactly what we wanted, right? So let's think about what we did. this was B1, and this is B2. We did 7 times B1 plus B2, right? And then replaced it, took that and put it into the C2 position, okay? So if we bring Alex back over, right? That means we can go down here. We took something times B1 plus B2 to get C2. So we did a 7 there, okay? So that's how we want to think about those. Okay, so now let's go back over here into our presentation and the next example. So, restaurant buys baked goods from a local bakery. The table below gives the number of loaves of bread, bags of cookies, cupcakes the restaurant brought over from the course of 3 weeks. So the restaurant buys no other baked goods from the bakery, and from no other bakery should be said as well. So week 1 and then week 2 and week 3 information for bread, cookies, and cupcakes. So we're also told here that in week 1 we spent $57 on baked goods. So that means that $57 is equal to some dollar amount for the bread plus some dollar amount for the cookies and some dollar amount for the cupcakes, right? So bread will be X, cookies will be Y, and cupcakes will be Z. Okay, we could have used other letters kind of thing, but there wasn't any like specific good ones that didn't overlap. So now we do the same thing for 2 and 3. So week 2 is 89, where we bought 9 bread plus 8 cookies plus 7 cupcakes. Then week 3, we had $68 for 8 bread and 4 cookies and 5 cupcakes. So now, well, right off the bat, we see that Y is probably a pretty good variable to eliminate. So, since we already have to change this one, let's multiply that by -2 so that we can then take that equation and eliminate with the other ones. So let's number our equations again. We have 1, 2, and 3. So now our 3 is also going to be, well, -2 times 68, well, times the entire equation actually, right? So 68 times -2 is -136 is equal to 8 times -2 is -16x minus 8y minus 10z. So now if we take, let's see then, 1 and 3, that is 57 is equal to 5x plus 8y plus 4z, and -136 is equal to -16x minus 8y minus 10z. So we add that down, and what is that? -136 plus 57 is -79. Then 5x and -16x is -11x. The y's cancel. Then we have -6z. 79, 11, and 6 don't have anything in common, so that's all we can do to that one for right now. This is equation 4. So then, next we want to take 2 and 3 together, right? So equation 2 is 89 equals 9x plus 8y plus 7z, and -136 is equal to -16x minus 8y minus 10z, and add together. So 89 minus 136 is negative 47. And then 9 minus 16, that's negative 7x. And no y's, negative 3z. 47, 7, and 3 don't have anything in common, so that's all we can do to that one for now, and this is equation 5. So, from this point, then, we can look for the next variable. Well, we have negative 3z and negative 6z. Let's multiply this one by what? Well, we don't want it to be negative anymore because this is already negative. And we want it to be 6, so let's multiply it by negative 2. So our new 5 is 47 times 2 is 94, is equal to 14x plus 6z. So that's 5. And so what we want to do is take 4 and 5 together, right? So that's 5. Let's write down 4 then. Negative 79 is equal to negative 11x minus 6z. Add those together, and we get what? That's 15 is equal to then 3x and no z's. So then divide by 3, and you get that x is equal to 5. There's our first part of the solution, right? So then we can go back into either 5 or 4. Doesn't matter, right? Let's go into, it doesn't matter on this one. Let's go into 4, just because, why not, right? So we have negative 79 is equal to negative 11 times 5 minus 6z. So I'm going to add the 6z over and take the 79 over. So we have 6z is equal to negative 11 times 5 is negative 55 plus 79. So that is 6z is equal to 24. Divide by 6, so z is equal to 4. There's our second solution. So next, we can find y from any of the first equations. Let's go into number 1. Again, just because, why not? I'm going to pop up here to the top part to have a little bit more space to work in. So we have 57 is equal to 5. We know x is 5 plus 8y plus 4, z is 4. So 57 is equal to 25 plus 8y plus 16. So 57 is equal to 25 and 16 is 41 plus 8y. So then 8y is equal to 57 minus 41 is 16. So that means y is equal to 2. There we go. So again, we can take that solution and plug it into equation 2 and equation 3 to check it. Okay, so our solution set, just to write it out formally, is 5 loaves of bread, 2 bags of cookies, and 4 cupcakes. Okay? Or, well, actually, $5 for a loaf of bread, $2 for a bag of cookies, and $4 for a cupcake. It's a very expensive cupcake, right? Better be really big. Okay, so now let's actually talk about what this section is on. Matrices. Matrices is just another way to write and solve a system of equations, okay? Now, we have kind of things that we can do with a matrice. We have rows and such. That's kind of the basic format right here of a matrice. A row here, row 1, row 2, row 3, 4, all the way up to whatever you stop at, in, we call it. Then we have columns, column 1, column 2, all the way up to column M. That's why this matrice is n by m, okay? So, Then the row operations we can do. Any two rows can be switched. They can switch places. Okay? Then any row can be multiplied by a non-zero constant. Any number you choose, you can multiply it, just can't be zero. Okay? Then any two rows can be added together, and then it can replace one of the rows. That's basically what we've been doing kind of with elimination especially, right? It's just now kind of just putting it in number format, not having to deal with the variables and such, okay? So let's do an example. We'll talk about the upper triangular and lower triangle matrices in just a second. Those are kind of the solution formats that we want to get to when we solve out a matrice. So the next thing is doing an example in Alex again. So this is a different filter. This is Gauss-Jordan, okay? So we want a completing Gauss-Jordan, elimination with a 2x2 matrix. Okay, so this is almost exactly like that other example we did. We're just trying to figure out what changed from one to the other. So here's where we start, the augmented matrix. Okay, augmented just means these are the coefficients of the variables. This is the answers to each equation. Okay, so if we wanted to write this out, notice they have it here. 6x minus 7y is equal to -1. And 3x plus 7y is equal to 5, right? So what did we do? We multiplied R1 by something. We looked like we divided by 6. So that's multiplying it by 1/6, right? Then what happened? So we multiplied R1 by something, then added it to R2. Okay, so looks like we got rid of the 3. So that would be multiplying it by -3, right? So if we multiply by -3, what happens? -7/6 times 3, well, the 3 would cancel out with the 6, right, to make it over 2. So that would make it +7/2. Well, +7/2 plus 7. Well, 7 is 14/2. So 7/2 and 14/2 is 21/2. Okay. So it looks like that's what we did. We multiplied by -3. So then next, what happened? We looked like we did something to R2. Well, R2, 21 over 2 went to 1. Well, to get rid of a fraction, we can multiply it by its reciprocal, right? So that's multiplying by 2 over 21. So now, what happened here? Looks like we multiplied R2 by something and then added it to R1. Well, we got rid of the -7/6. So that means we multiplied by 7/6. It was already negative up here, so we didn't need a negative for R2. So what happens then to the kind of augmented portion, the solution column? That's what we call it. So we didn't do anything to R2, so that's still 11 over 21. Now, the top one, we multiplied by 7/6 and added it to R1. So we had 7/6 and 11/21. So 11/6 and what was it? And 11/21 times 11/21. So this was a 7 as well. 7/6 and 11/21, right? So what we're doing is we're saying we have 7/6 times 11 over 21, and then we need to add it to what was there in the augmented portion of row 1, which was -1/6. Okay, so we need to add this to -1/6. So let's multiply these first. 7/6 times 11/21. Ugh, already, right? So that's 77 over 6 times 21. That would be 126. Plus then -1/6. Well, we need to get that to be 21 times 6 in the bottom. So that's 77 minus 21 over 126. That's what, 56 over 126. We can take a 2 out of both. So 56 divided by 2, that's 28. 126 divided by 2, that's 63. Well, then, let's see. I think that's it, maybe. Or can we take a 7 out? I think we can take a 7 out. So divide by 7, divide by 7. That's a 4 over, that's 21, so that's 3 and 3, that's 9. So that's 4/9 then. So that should be our new solution for right here, 4/9. So then our solutions, the top one is x, because this is the x column and this is the y column, right? So x is 4/9 and y is 11 over 21. Okay, so that's that example. Okay, so then the next example is Gauss stored in elimination with a 2x2 matrix. Okay, so that's just one of those other ones that we had right here. So this is you doing all those steps on your own, okay? So it's telling you what to do though. So it's not too bad, okay? And then also, I wanted to just talk about that one. Then we can do almost that exact same thing that we just did together, but with a 3x3 matrix. So there's kind of 3 rows and columns and things to look at, okay? But it's the same thing. All right, then this is the last example that I actually wanted to do out with you. So if we look here at this matrix, we can see that we've almost already kind of got it there, right? We almost have, well, we know what z is, we know what x is, we just don't quite have what y is. So we can do a couple row operations to figure that out. So we want to do -2 of row 1 and add it to row 2. So let's figure out what -2 of row 1 is. That would be -2, 0, 0 of positive 23 halves. And now we want to add it on. So that's a 2, a -4 is 0 for row 2, and a -71 over 2. So if we add these together, what do we get? Well, 0 and a -4 and a 0, and then 23 and -71. What is that? So we have 23 minus 71, that's -48 over 2. Well, that can be simplified. That's just -24, right? So our new matrix is 1, 0, 0, -23 fourths, 0, -4, 0, then -24, 0, 0, 1, 2. Now, the very last thing we want to do is get this to be a 1. So, just divide by -4. So, row 2 over -4. That gives us 1, 0, 0, -23 fourths, 0, 1, 0, positive 6, 0, 0, 1, 2. So right here, we can literally look at this matrix and pull out our solutions. So x is equal to -23 fourths, y is equal to 6, and z is equal to 2. Okay? So I will be posting another separate video on a little bit more on what to do with matrices if you're interested. All right, but that is the end of the section.